Okay, those who came in earlier, thanks sir for turning on your camera. Those who came in earlier, I have shown you the video of mashed potato. Okay, let me just share screen, a whiteboard. It's not really it's something extra that I just want to help y'all with. Just a minute. I just realized that. Okay, I'll try to write it here. So you have mashed potato. All right. So MASH. So you all know what M stands for is metal. So you have metal reacting. I'm using my finger to write, all right? Because I think, yeah, now I can find my pencil. Okay. Metal plus. Do you all know what A is? Anyone? Metal plus. A stands for acid. All right. So when you have metal plus acid, you will make two products. So that will be salt. All right. Plus hydrogen gas. All right. Salt plus hydrogen gas. So you can remember it by MA. All right. MASH. Okay, mashed potato, my favorite food from KFC. Okay, so metal plus acid give you salt plus hydrogen gas, and hydrogen gas you can test it and you will hear a beautiful pop sound. That pop sound is actually a small explosion. All right, so this is for people who have come in earlier just now. Okay, so I showed you the video. Okay, so I hope this mashed potato MASH helps everyone. So let me stop share. All right, so we'll go to today's slides, which is on particulate nature of matter. So as usual, anything that you don't understand, please feel free to type into the chat. Okay. Right, the starless words. Okay, let's start. Now, this part is testing everybody. So we have a very, very, very small class. So I really, really appreciate if everybody can contribute to this table. So I have 5 of you. So each person will take one box. How about that? Okay, so any volunteer to tell me arrangement of particles in a solid? We're going to play games later, so can we do faster? If it's okay to give me the wrong answer, we are here to learn from each other. All right, Ethan, would you like to try arrangement of particles in a solid? You can unmute yourself, or some of you have typed in the chat. Javier, thank you. Nico, thank you. All right, so it is very closely packed. Ethan, you want to give me the rest of the answer? So you need very.
It's closely packed, right?
Thank
Cannot
you.
move.
Okay, so you use the word move. Thank you very much for your response. Do you see M for move?
Vibrate,
So
vibrate.
no. Moving, whether you write move or whether you write vibrate, you are using this. You are filling up this box. I am talking about this box here. Okay, so the particles in a solid are very closely packed. All right, very closely packed is half the mark. How to score the other half a mark in a what kind of arrangement?
Organized.
Organized arrangement. All right, I will prefer the word orderly. All right, orderly arrangement. So that is the second point. Okay, now, thank you, Ethan. Javier, would you like to give me the arrangement of particles in a liquid? Okay, closely packed. So instead of very closely packed, it's just closely packed. And then that's only half a mark. So you see, most of you only score half a mark. You need to give me another one. In a, is it orderly?
Unorderly manner.
Random.
Okay, either you write random. Actually, English is called disorderly. All right, you can also write random, no problem. Okay, either write disorderly arrangement. Okay, so this word can also be random. Some books write irregular. Actually, they all mean the same thing. That means, imagine this is a naughty class. This will be an arrangement in a naughty class. Everybody run all over the place. Not, the tables and chairs are not straight. So this orderly arrangement. So orderly, some people will write regular arrangement. Okay. But you normally don't use the word organized arrangement, but the meaning, I get what you mean, okay? But usually we write orderly, disorderly. How about gas? So can I get Nicole? Arrangement of particles in a gas, please, Nicole? Widely spaced, all right, meaning far apart. All right, very, very far apart. The particles are very far apart. This is again half a mark. Can you give me the next half a mark? Yeah. So in a disorderly arrangement. Okay, you can also write regular, sorry, you can write random, irregular. Okay, so all these are talking about arrangement. All right, so don't get the words mixed up. So here will be very closely packed. Right, where else here is just closely packed. Then here is far apart. Then the second part to read is whether it is orderly, whether it's disorderly. All right, so there are two parts to read. So the marking points is 2 marks. All right, so in other words, you have to get 2 points, 2 marking points in order to score the full marks. All right, so this is not the first time we are going through this, so I hope everything is actually in your mind. All right, now let's move on to movement. Just now was arrangement of particles. Now it's movement of particles. Can I have a Sherman to give me movement of particles in a solid? Vibrate, okay, vibrate, good. Is only half a mark. So what is the other half a mark? You know, it could be maybe the particles vibrate here, and then another particle vibrate here. Okay, maybe they're closely packed, right? So they vibrate here. Then after that, what you're saying is after that, 1 second later, they move. All right, this one vibrate over here, then this one vibrate over here. Is that what you mean? Because you
Vibrate
just say
closely.
vibrate. Say again, vibrate again.
Closely.
No. Closely. Do they have fixed position or do they not have fixed position? Do the particles in a solid have fixed positions? Yes. All right. Thank you, Javier. All right. So we will write about fixed position. That is the second part. All right. So there's 2 parts, 2 marking points again. All right. So let's talk about liquid. Zeyu, would you like to try?
Slide over each other.
Okay, good. So slide, instead of vibrate, is slide and then over each other. All right. And then for gas, either you write over or you write past each other, same thing lah. Okay, then for gas, 1, 2, 3, 4, 5 of you. Okay, then Ethan, we go one more round again. Movement of particles in a gas. Do they vibrate? Do they slide? I'll just say they move. How do they move? What is the speed like?
They move fast.
Very fast. All right, so they move quickly. And then how do they move quickly? Do they all move? Everybody move to the right very quickly. Then the next second, everyone, all the particles move to the left quickly. Or everyone, 1 second later, everyone, all the particles move very quickly. How do they move? What is the direction? Okay, good, Javier. Okay, so it's in all directions. All right, that means you can also write randomly. Randomly simply means any old how lah, in all sorts of directions. So this is the marking point. All right, so either you write in all right directions or you can say randomly. So randomly means any old how, some go up, some go down, some go right, some go left, and they move very fast. All right, so the diagram is there. Now forces of attraction, can we go back to Javier? What is the forces of attraction here? What are the forces of attraction between this particle and this particle? What's the forces of attraction? Do you know? Oh, I could see you in the chat. Okay, very strong. All right, so you have a very word just like this word very. All right, so let me highlight in yellow. So you have two very words. Then how about the forces of attraction between the particles in a liquid will be, next person will be Javier. Javier? Okay, Javier, you wrote down, now it's Javier's turn, right? Oh, Javier answered very strong just now, right? 1, 2, 3, 4, 5, 1, 2. I'm like taking attendance. Then Nicole. Nicole, what is this answer? Okay, can we do a little faster, please? Or anyone type into the chat or unmute yourself. So the force of attraction, no. Here is very strong. Okay, I give you a clue. You look on top. Here is very closely packed. Then here is closely packed.
Strong.
Yes, so these two are similar except here got very. So similarly, very strong, then strong. Okay, so this is how you remember there's a pattern. So here is just strong. So between this particle and the forces of attraction to this particle, they like each other quite well. They like each other quite a lot. But this particle and this particle, they love each other very, 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 very much. Very strong forces of attraction. How about for particles in a gas will be weak. Either they write weak or very weak. Right? Some textbook write very weak. Okay, so please remember all this by heart, all right? Because if the question comes out, it's really Santa Claus giving you free marks. Don't need to apply. This is just plain memory work. All right, so I already typed out nicely for you here. Next, sublimation, let's just revise. Okay, so we have solid, liquid, gas. So whenever you go right, solid change to liquid is gain heat. Liquid change to gas is gain heat. All right, so go right is always gain heat. How about opposite direction, go left? Gas must lose heat to become liquid. Liquid must lose heat to become solid. So going left is lose, and I have already taught you all the way to remember if it helps you. Different people remember it by different way. So if you move left, right, left start with letter L, right? So lose heat. So move right will be gain heat. Right, this is just a simple memory aid. If you tend to always get confused, that might help you. Right, then all the name of the processes, solid change to liquid is melting. That means melting is solid change to liquid. Then liquid change to gas is either boiling or evaporation. Right, then gas change back to liquid is condensation. Liquid change back to solid is freezing. So there are some examples of chemicals that sublime, means they jump the liquid stage from solid state change to gaseous state. So they don't even become liquid. So go this way. All right, so change from solid to gas directly. Now gas change back to solid is deposition. Right, can everybody type into the chat? If I give you a 1 mark question, what is sublimation? Can y'all type into the chat? Please see who can get me full marks. What is sublimation? 1 mark question. Everybody type into the chat. What is sublimation? 1 mark. So you have the concept in front of you, but how do you type it out? What is sublimation? It's a change from what state to what state? So sublimation is a change from right? So sublimation is change from solid state, right, to what state? Can someone tell me the answer? Solid gain heat and change from solid to gas. Okay, Zhe, good try, very, very good try. You just miss out on one important word at the last. Javier, sublimation is a change from solid to gas without entering the liquid state. Okay, Zhe and Javier, well done, except you all miss out on the very, very okay, Javier has a concept. You're telling me without entering liquid state. In other words, you might score full marks, but then easier way to say is just directly. Just one word, directly. So this word directly, right, simply means it will bypass the liquid state. It will not go into liquid state. All right. So for Zhe's answer, you did not write down that it skips the liquid state. So you need the word directly.